It's 2026 and the global chip race is on. Across the world, governments are scrambling to capture a segment of the lucrative market for semiconductors and integrated circuits, the building blocks of the modern economy. Integrated circuits, or chips, are now an essential component of virtually every type of electronic device, from washing machines to smartphones. Due to breakthroughs in AI and cloud computing, chip demand is higher than ever. Global exports of integrated circuits doubled between 2016 and 2024, jumping from $414 billion to $818 billion. In addition to being extremely lucrative, control of chip supply chains has become central to the strategic competition between the United States and China. Southeast Asia has long played an important role in these supply chains. The region currently accounts for around 26% of global chip exports, up from around 20% 2 decades ago. But more important is what lies ahead. As Western countries move to de-risk semiconductor supply chains, this is creating opportunities for Southeast Asian states that want to expand their role in global production networks. Once peripheral players in assembly and testing, they have the potential to establish themselves as critical nodes in global chip production and investment. 6 of the 11 nations of Southeast Asia are making a concerted effort to carve out a role for themselves in the semiconductor industry: Indonesia, Malaysia, the Philippines, Singapore, Thailand, and Vietnam. Today, we're looking at which countries are succeeding and which are falling behind. To understand Southeast Asia's chip race, it is important to understand the nature of the global supply chain for integrated circuits. While less sophisticated chips are sometimes designed and produced in-house by a single company, supply chains for the most cutting-edge semiconductor circuits are complex and dispersed across the global economy. The most important of these steps require huge investments and are dominated by a handful of companies. This also creates very high barriers to entry for aspiring chip powers. At the start of the chain is the software used to design integrated circuits. This link is currently dominated by 3 major companies: Cadence and Synopsys in the United States, and Mentor Graphics, an American firm that was acquired by Germany's Siemens in 2021. Next comes the design work itself, which sees companies use the software to produce proprietary chip designs. This stage is also dominated by the US, which holds around 43% of the global circuit design market, followed by South Korea and China. Then comes the manufacturing, or fabrication, of chips. This, too, is a very expensive process that is dominated by a handful of companies. The biggest manufacturing facilities, or fabs, are Taiwan's TSMC, South Korea's Samsung, China's SMIC, and the multinational Global Foundries. The final link in the chain is assembly, testing, and packaging, or ATP, where the chip is packaged and prepared to be shipped to market. This is the least complex link in the chain, and consequently where the barriers to entry are lowest. However, it's also the least profitable, for the same reason. It is here that Southeast Asia comes into play. The majority of the value created by chip production in the region currently comes from outsourced semiconductor ATP processes and the manufacture of less sophisticated chips. However, the region's governments dream of moving up the value chain. In recent years, and particularly since the beginning of the AI boom, Southeast Asian countries have pursued a series of distinct industrial policy models in an attempt to gain a strategic advantage in the chip space. Follow-through has not historically been a strong suit of these big-picture economic plans. Let's hear from James Guild, a Singapore-based expert on the region's economies.
A lot of that manufacturing activity could be moved to any number of countries in Southeast Asia that create the right investment and industrial policy conditions, because they're very complicated supply chains, right? You need to have engineers, you need to have people who are properly trained, who can do design work. What we're seeing is a push in Southeast Asia generally to get more into the design part of it, and particularly more into the physical manufacturing and fabrication of the wafers. And we're starting to see that across various different countries. They love announcing roadmaps in this region. Following them, getting a credible path to achieving that's another question, right?
Here's where the 6 main players currently stand. Let the countdown begin. Coming in 6th place is Indonesia. Of all the major Southeast Asian economies with a presence in the chip space, Indonesia lags far behind the pack. The nation exported an average of just $693 million worth of integrated circuits in 2024, less than 0.1% of the world's total. Earlier this year, the country announced a national roadmap for developing the semiconductor industry, which aims to build out the necessary talent. But while Indonesia does have industrial ambitions, it has chosen to focus its efforts in other areas, particularly electric vehicle batteries and clean energy. There hasn't been much progress in chip making specifically.
They don't have a very well developed industrial ecosystem to support semiconductor manufacturing. There's no fabrication facilities. Semiconductors and computer chips and electronics that Indonesia is shipping, they would be involved in the final stage, the lowest value added, packaging, testing, and assembly. And even then, it would be quite small, I think. Now, where Indonesia probably has the most leverage is in the development of critical minerals, the raw inputs that make semiconductors.
One place where Indonesia could potentially play an important role is in the supply of gallium and germanium, critical minerals that are central to semiconductor production. If Indonesia can't move up in the value chain for chip making, it may be able to carve out a niche in processing and advanced handling of the raw materials, just like it's trying to do for nickel and the battery industry. Coming up next, in fifth place, is Thailand. In 2024, Thailand exported $8.5 billion worth of integrated circuits, about 1% of the global annual total. The country has hovered around this level for much of the past 2 decades. In some ways, it is surprising that Thailand isn't further ahead in the chip race, given the country's long-term focus on exports and manufacturing. Thailand's government is currently keen to redress this shortcoming. In January, it launched a long-term national roadmap to turn itself into a regional semiconductor hub, aiming to attract over 2.5 trillion baht, around $80 billion, in investment over the next 25 years. The government plans to train 230,000 engineers, upgrade research and development, and develop specialized infrastructure. It will also offer investors financial incentives and streamline regulation in order to encourage foreign investment in the chip space. In particular, this initiative will focus on developing specific high-growth potential chips to support key industries like electric vehicles and AI. The core strategy is to transition the country's industry from basic assembly and testing to higher-value sectors like chip design and fabrication. Thailand's relative sophistication in export-oriented manufacturing will work in its favor. However, the country's current economic challenges and endemic political instability may end up complicating the government's ambitions.
Out of all the countries here, Thailand's economy is probably facing the biggest challenges and headwinds at the moment. So they're maybe not in a great position to break ground on a new technological frontier that's very capital and technology intensive. But certainly they could do it if they dial in the right policy mix and political leadership, which we know has been a challenge for them in the last couple of years.
In fourth place is the Philippines. Semiconductors and integrated circuits are the country's biggest exports. In 2024, the country exported around $19 billion worth of integrated circuits, which made up around 14% of the country's total exports. This represented 2.5% of the global total, making the Philippines the 10th largest chip exporter in the world. The country is now home to major global players in the semiconductor and electronics space, including Amkor Technology, Texas Instruments, and Samsung. However, most of this activity is at the lower end of the value chain, in outsourced ATP services and in the manufacture of the most basic types of chips. To bolster its presence in this space, the government created a Semiconductor and Electronics Industry Advisory Council in April 2025. This new body, composed of public and private sector representatives, is tasked with crafting strategic policies to strengthen the global standing of Philippine electronics. A key focus is boosting the country's share in the global semiconductor value chain and helping manufacturers transition toward higher value, innovation-driven production. One advantage that the Philippines has is its close relationship with the United States. The U.S. considers it a priority partner for bolstering supply chain resilience, a fact that could help it move up into more advanced, high-value links of the chip supply chain. But here, political chaos in the U.S. may be holding the Philippines back.
You would think that the Philippines would be a natural partner for the United States in developing semiconductor supply chains that don't run through China, right? And since they are a natural ally of the United States in many ways. But we really haven't seen that develop to the extent that it probably should. And I think that's more of a lack of vision on the U.S. side. The Philippines, it's open. They're trying to make the reforms to make their economy more pro-growth, more industrial friendly for this kind of industrial production. It's just a matter of finding the right partners that's going to help them get there.
In third place comes Vietnam, which is currently making the quickest moves in the regional chip race. Despite being held back for years by conflict and Cold War rivalries, the country has rapidly industrialized and is now the 9th largest chip manufacturer in the world. In 2010, Vietnam exported just $315 million worth of integrated circuits. By 2024, that figure had reached $27.8 billion, accounting for around 3.6% of the global total. Like its rivals, most of this growth has taken place in the ATP space, where leading firms such as NVIDIA, Intel, Amkor, Hana Micron, and Samsung have all established a strong presence. But Hanoi is also looking to move up into design and fabrication. The 2024 National Semiconductor Strategy aims to create 100 design firms and 1 fab by 2030, expanding to 300 firms and 3 fabs by 2050. To support this, it aims to train up to 50,000 semiconductor engineers by 2030. Realizing that it will struggle to compete with the main Taiwanese, Korean, and US firms, it has focused on specialized or application-specific chips. Vietnam has several advantages: a skilled, low-cost workforce, and proximity to China-centered supply chains, which have already made it a prime choice for companies wishing to diversify their manufacturing operations away from China.
Vietnam is making really big leaps in this kind of export-oriented industrialization and manufacturing. What's interesting about Vietnam, if you look at the composition and structure of its exports, it's heavily focused on electronics of all kinds. They're doing everything right. They're really open to this kind of direct foreign investment from more technologically and well-capitalized foreign partners in South Korea, China, or whatever the case may be. They come there, they build their industrial parks in Vietnam, they produce their components, and then they export them. So in terms of the political economy and the structure of their industrial ecosystem, they're very well placed to take advantage and become a leader, probably, in semiconductor supply chains.
And there's more. In January 2026, Vietnam broke ground on its first fabrication facility. The project is not being undertaken by a foreign firm, but by a homegrown, state-owned company, Viettel, which is owned by Vietnam's Ministry of Defense. That's a clear sign of the national security motives for Vietnam to break through in the chip industry. Trial production is supposed to begin in 2027. If you want to keep an eye on Vietnam's move up the semiconductor value chain, watch the future of this fab closely. With the ruling Communist Party seeking an ambitious economic growth target of 10% per year until 2030, Vietnam has the potential to move from a promising alternative to a credible and strategic core player. Coming second in Southeast Asia's chip race is Malaysia. The country has decades of experience in electrical and electronics manufacturing and has established itself as a global leader in back-end chip processing. Most of its semiconductor and chip production takes place in the sprawling industrial parks around Penang, which were established in the 1970s, and in the nearby Kulim High-Tech Park, which was set up in the 1990s. As a result, Malaysia has established a robust chip manufacturing base. The country currently boasts 10 semiconductor manufacturing facilities, including production facilities for the US chipmaker Intel, the German firm Infineon, and other leading Western and Chinese firms. In 2024, Malaysia was the 5th largest chip exporter in the world, selling just over $70 billion worth of integrated circuits globally. The government is intent on building on this foundation and has set up chip design parks in Puchong and Cyberjaya.
Malaysia has always been very good at integrating into global supply chains. They usually don't manufacture everything from end to end, so they don't make an entire airplane. Indonesia tries to make an entire airplane. Malaysia doesn't try to make the airplane, but it tries to focus in on certain links in the supply chain, manufacturing certain high-value parts of the airplane, right? Or doing maintenance and repair services that generate a lot of value, but they don't necessarily dominate the supply chain from end to end. And I think we'll probably see a very similar approach with semiconductors, where they are focusing on capturing a lot of the value in specific high-value niches in the supply chain.
The National Semiconductor Strategy, announced in 2024, envisions Malaysia moving into more advanced packaging and chip design. Under the strategy, the government will offer $5.9 billion in fiscal support and train 60,000 Malaysian engineers to meet industry demand. In doing so, it hopes to attract 500 billion ringgit, around $107 billion, in investment for its semiconductor industry. In making his pitch to the world, Prime Minister Anwar Ibrahim has focused not just on Malaysia's experience in electronics manufacturing, but also on its geopolitical position as a neutral and non-aligned location for semiconductor production. The implication is that Malaysia can make chips for all buyers, China, the United States, and beyond. This brings us to the undisputed leader of Southeast Asia's chip race, Singapore. Like Malaysia, Singapore has decades of experience in electronics manufacturing. In 1968, the U.S. firm National Semiconductor Manufacturing became the first company to invest and establish a facility in Singapore. Today, Singapore is the one Southeast Asian nation that can be rightly described as a semiconductor powerhouse. While Singapore's state investment fund, Temasek, made the strange decision to exit the semiconductor business in 2009, the city-state leads the region in research and manufacturing activities. This includes all phases of the semiconductor value chain, from integrated circuit design and wafer fabrication to packaging and testing. In 2024, Singapore exported $77.8 billion worth of integrated circuits, making it the world's fourth largest chip exporter. 1 in every 10 chips worldwide is manufactured in Singapore, and the country accounts for around a fifth of the world's semiconductor equipment output, according to the Economic Development Board. As of 2023, the semiconductor industry contributed nearly 6% to Singapore's GDP and employed more than 35,000 people. While Singapore has not produced a local champion in the chip space, it has proven attractive to global industry leaders. Singapore has 17 semiconductor manufacturing facilities, the most in the region, and some of the most advanced. The city-state is home to hundreds of foreign and domestic semiconductor companies, including the multinational Global Foundries, Taiwan's Vanguard International Semiconductor Corporation, the U.S. memory chip specialist Micron, and UMC, Taiwan's second-largest chipmaker. Singapore is also not likely to rest on its laurels. In February 2025, Prime Minister Lawrence Wong announced plans to invest about $790 million for a new semiconductor research and development facility to help preserve the country's technological edge. Singapore's political stability, long-term planning, and heavy investment in R&D are likely to keep it the undisputed leader of Southeast Asia's chip race for the foreseeable future. At the same time, it's clear that Singapore's neighbors are coming for the crown.
They're at a more advanced stage than the other countries in the region. What does Singapore have to do to protect that lead as countries like Vietnam rise up the value chain? How well did they do it? How quickly can they rise up and capture more value in these more advanced links like design and fabrication and actually give Singapore a run for its money? I think that will be something very interesting to watch in the years ahead.
Collectively, these 6 countries have pledged billions toward raising themselves up the semiconductor value chain in the coming years. The crucial geopolitical importance of chips and the desire of the U.S. and other Western powers to diversify semiconductor supply chains has created opportunities for Southeast Asian governments. The crucial question is which countries have the ability to convert their roadmaps to reality, and whether those efforts actually succeed in creating supply chains that aren't anchored on China. Thanks for watching The Diplomat Asia. Semiconductors aren't the only geo-economic flashpoint reshaping Southeast Asia. Critical minerals are another. For more, check out our video on China and Myanmar's rare earths.